because I'm presenting today. I was like, I'm gonna take it easy, and it was good until like after Crystal Method and stuff. But I don't know how I ended up getting this Liver Strong bracelet. And after that, I just felt like Superman. Like, oh, I can drink everything. I'm Liver Strong, you know? And shots got up control, but, you know, I made it. I have good stuff to show you today. I'm sure you guys all love it. All right, so this talk, in the presentation, I sent the wrong title. New exploitation and obfuscation techniques, but by exploitation, we'll be talking specifically about optimization and obfuscation techniques that we can use. Before I get started, I'm just going to quickly present myself. I'm Roberto Salgado. I'm co-founder of WebSec that we started in 2010. It's basically just an information security company that provides security solutions through pen testing, monitoring, and training. I also created the SQL injection knowledge base. A few of you might have heard of it, maybe. It's a really complete reference for everything you really need to know about SQL injections, except how to defend against them. But there's links to other pages that show you that there. But it has a lot of neat stuff, and I've been basically putting all my knowledge on SQL injections in there. I'll be showing it to you later. Also recently, I've become a fan of Python. It's a great scripting language, a great hacking language for programming. So I now consider myself a Pythonista. Just recently, I wrote this tool called Panoptic. It helps for exploiting local file inclusions. So you have the local file inclusion, and you can't really convert it to an RFI or something. So your only option may be just to try and find like sensitive config files, log files. So what this program does, it has a list of thousands of different paths for sensitive files, for configuration files, and log files where you can find passwords, and it'll search all those files through a local file inclusion. But okay, I'm not going to spend too much time talking about that. There's my contact information. If you want to follow me on Twitter, I also post like all my new research mostly on Twitter. All right, so we start talking about some analysis of some blind SQL methods that we can use to optimize blind SQL injections. Then I'll talk about some optimized queries, like just single queries that can use to do a lot in a database, like instead of having to send multiple queries and exhaust resources. Then in obfuscation, I'll just be showing fuzzers, how we can use fuzzers to find different obfuscation methods and stuff, stuff that can help us, how we can apply it to bypassing firewalls. And talk about some encodings too that can also be used for bypassing firewalls. And at the end, I'm just going to quickly mention my tool Leapfrog, which it's a tool I've been slowly developing over last year that helps you test the rules of firewalls and to just see how secure your firewall is, and it tries to provide some solutions as well to help you improve your firewall rules. So this comic here, Bobby Tables, it's like in 99% of all SQL injection talks you'll see. But Bobby's Robert, I'm Roberto, so I feel it's more suiting to me, so I use it, screw everyone else. This is my one defensive slide in the whole presentation, bobby-tables.com. It's a great resource if you want to know how to protect against SQL injections. It shows you how to defend in almost every programming language available. So optimization. Why do we really care about optimizing our queries, really? There's a few reasons. One, it will save bandwidth. It will use less resources, less network congestion. But for me, the most important reasons is we get faster results. All of the times, it's not like unheard of that someone's attacking a database and the firewall picks up the alerts and the system blocks that injection or blocks you right away and you can't finish attacking the target. So with a lot of these optimization techniques, we can use them to really get maybe all the database and information or everything we need, conduct an attack in just a few seconds without really triggering many alerts to give the team enough time to block you or try and stop you. So talking about the blindness SQL injection methods that we can use, we start talking about the bisection method. I think it's nothing new, but it's important to mention it just when comparing it to the other methods. Bisection method is kind of the standard. Everything uses the bisection method. It's pretty easy to implement. Then we'll talk about some regular expression methods, bitwise operator methods you can use, and then my own method that I came up with, the binary superposition. So a quick reminder, we usually, in this case, I'm talking about blind SQL injections because we usually can only retrieve one character at a time when we're explaining through a blind SQL injection by testing through true and false response. So that's why it's more important to kind of focus our optimization in blind SQL injections, because I mean, if you have a union maybe, then you can just union and kind of dump your whole results in one request. But with blind SQL injections, it will always be multiple requests. So it's more important to focus our optimization on blind SQL injections. Before we jump right into it, I just quickly mention the ASCII table. The ASCII table stands for the American Standard Code for Information Interchange. And it's basically, it was invented because computers understand numbers, so we need a different way to be able to represent letters and different characters based on those numbers. So then we have all these different bases, like base, binary, octal, decimal, hexadecimal, and it can all have its equivalent. Like this is A, the different ways to represent A in all these different bases. This is what the ASCII table looks like. Basically, you just have the decimal, hex, octal, and the character representation value of that code point. And when we're talking right now about SQL injections, we're not interested in the whole ASCII range. Usually, we're only talking about starting from decimal point 32 all the way to 126, because these are just like control characters and stuff, and then like 127 is the del. So you don't really find that in like a table name or in database information, so we don't need to focus on those. We can skip those or ignore them. So for this reason, like the range we're interested in, this is the whole range, what it covers in binary, but the range we're interested in is only from up to 127. And if you look at the binary for up to code point 127 or 126, the most significant bit never gets used, it's always off. So we can ignore this bit, and this will be important when we're talking about the bitwise methods. You'll see how it will come in play. So starting with the bisection methods. The bisection method is commonly known as the binary search algorithm, like computer scientists and stuff. As I was saying, we only consider the range 32 to 126. What you do is you have an array or a list, and you split it in half and check each half for the value you're looking for. You check if the value is greater or less, check both sides, and then you repeat. You split whatever side the value was again in half and keep on dividing. It's a divide and conquer algorithm. So it's really effective. This is kind of just what the bisection method looks like. Just looking for the decimal character 97 or A. And again, that's a little graph to show you. You have your set of characters, you split it in half, and then you check each half, and then split that half again. So with the bisection method, which I was saying is the most common method implemented in every almost SQL injection program you'll see, uses the bisection method. It's straightforward. It's been around for a while, easy to implement. And generally, when running the bisection method, to get one character, the RPC is kind of just a little term I coined there, an acronym, request per character. So it takes around 6 or 7 requests per character to the database or to the web server to get one character back. One of the cons about this method is it's the same, or the best case scenario, average case scenario, worst case scenario, they're very similar. It's always 6, 7, it doesn't really vary from that. The other method, the regex method by Simon, Root ATI, and then White Sheep, it's essentially an adaptation of the bisection method. It has the same logic behind it, but it uses regular expressions instead. I'm not going to talk too much about it because it's basically a bisection method, but just adapt it using regular expressions. It's kind of neat. one of the pros is that you don't necessarily have to convert it to decimal. You can just put the characters right in there. So if you're doing this exploitation manually, it might be a bit easier for you to conduct. Yeah, and it's the same amount of requests as the bisection method, basically. So the bitwise methods. Each character in the ASCII table can be represented in 7 bits for the range we're interested in. The most significant bit, as I was saying earlier, is always going to be 0, so we can kind of ignore that. So for the bitwise method, since we're retrieving bits here, we only need, the maximum amount of requests we'll need is only up to 7 bits, because the 8th bit is always going to be off, so we can just assume it's always 0. So all of these bitwise methods I'll be showing, they're kind of variations of each other. Some use shifting, like this one, by Jelmer Dehen. And he did a bit of a weird implementation here. Like, it starts off good, where he's shifting. Remember, 97 is the decimal for A. So he's shifting, 7 and compares it to 0. So 0 is 1 bit. So he just checks if it's 1 or 0, and then gets the result. And he's comparing to 1 bit, 0, 1 or 0. But then at the third point, he starts comparing to 2, which is 3 bits. So now he's comparing it if it's 0, 1, 0 or 0, 1, 1. And the only issue with this is that it doesn't really allow for threading. If you're implementing this method in a program, you can't, because your result will rely on the previous result. So you can't really adapt threading to this method. So that's kind of a con. With these bitwise methods, most of them will always use 7 requests per character because you're just retrieving each bit, so with 7 bits. Like I was saying, it has the weird implementation because you can't use the threading. There's no reason for him to compare it to 2 bits at a time or 3 bits. You could have kept on doing it one at a time. This is like how I guess I would have done it. So instead of comparing it to 2 bits at a time, you compare it to just 1 bit. With MySQL and MySQL, or Microsoft SQL, you can substring binary. Like, binary is treated just like as a string, so you can use the substring function and just select each binary digit and then get your value that way. So, yeah. So here I was saying you can just substring the binary and then check if it's 1 or 0, and then you'll get your like 0, 1, 1, 0 here, 0, 1, 1, 0. You start getting your result by just doing the binary search. So this is a variation of the bit shifting method. Instead of using shifting, we're using ANDing here. Same logic, we're just ANDing A to 1, and then we test, we get 1 back. Same thing with 2, 0, 0, 1. So we start getting this value here, 0, 1, 0, 0, 0, like using ANDing. And again, with these methods, the pro is that the requests are always consistent, so I always know it's going to be 7 requests to get a character. But at the same time, it will never be less than that, so that's a con, I guess. But with this method, like, you can use threading compared to the first method I showed. So I'll be an optimization right there. Now to talk about my method, which is, of course, my favorite. Just like with the binary search or the bisection method, we require a set of characters, an array. Again, 32 to 126 decimal. With my method, what we do is we map the position of the character in the array. So say we have A, B, C in our set. A would be position 1. B would be position 2 in this case. So the closer the character is to the beginning of the set, the least amount or the less amount of requests we need to retrieve it, because we're mapping its position of each character. We're mapping its position in the set, and then we convert that position to binary. So instead of having to look for maybe 94 characters, which would be like 32 to 126 or something, we only have to look for 2 characters. Is it 0 or 1? Because we're converting that position to binary. So because a larger set will mean more requests for characters that are towards the end of the sets. We can specify our set, so if we know we're retrieving maybe an MD5 hash or password, we could just use a hexadecimal set. We could have a set with no capitals, like in this case. Depends because unless we really need the capitals. So our largest set, maximum, there's like 94 characters, so our largest set will be this, which is 7 digits. So I'll explain this in a bit, but basically our max amount of requests, or our minimum amount of requests will be 1, because if it's in the first position, binary for 1 is just 1. So that would only be 1 request because we just have to retrieve the 1. And then our worst case scenario, 94, which would be like if the character was in the last position in the set, then we'd take 6 requests in this case. This is what the method looks like. I put in bold what was important to me, like we have our set here. In this case, this is a hexadecimal set. I'm just getting the position of the set of the character it's found, and then converting that to binary. So essentially, using this lowercase set for this example, say we're retrieving character set from a database. C is in the 3rd position in the set. So we map 3 for C, convert 3 to binary, and that's just 11. So one thing you'll notice is that all of them start with 1 because we start with the on bits first. So we already know that the first digit or the first binary digit is always going to be 1. So we don't have to make that extra request since we know it's 1. So in this case, we know that this one's going to be 1, and then we just have to make an extra request to see the next one. Okay, this is 1. Is there anything else after this? No, there's nothing. So we knew that the first one was 1 already. We make 1 request to get the second digit, and then an extra request to check if there's anything else, if that's the end of the binary string. So basically, to retrieve the character C, we're only doing 2 requests to get that character. And then say for A, in this case, A is in the first position. So 1 is in binary is just 1. So we just need 1 request really to get the character A. And there's no other method that can retrieve a character in just 1 request without doing some fancy tricks and stuff, which is kind of cheating. So this is just the logic I just went through. We know the first digit's 1, no request required. Is the second digit 1 true? How about the third digit? False, there is no third digit. So the total request for C, just 2 requests. We can take this a step further. Since I was mentioning that the order or like the position in the set is really important for the amount of requests you'll be doing, we could always have our sets be adapting or changing, almost like on your cell phone. You know, you have the predictive text. So you're typing, and based on what letters and what words you're using, it predicts what's the most probable word or letter after. So you can use digraphs or trigraphs and stuff in your logic, implement that in your program. So your set will always be adapting. Like the most common letter for a word to start with is T. I mean, the most common letter in the English language is E. So, I mean, but it's more likely that a word will start with T. So using that logic, you can first put T at the beginning of your set, and then based on T, the most likely letter to follow maybe is an H. So you could move your set after that request and put H in front. So you'll be only doing very like 1 or 2 requests per character. So that's an interesting thing, just that could be adapted to the technique. I haven't tried it out yet, but I might do that. So with my methods, it only takes 1 to maximum 6 requests per character. And you think it'd be 7 requests max, but since we know that the maximum amount of requests is 7, if we're already at the 6th bit, we don't need to test the 7th bit because we know it's going to be 1. So if we're already at the 6th bit and there's 1 more, we know it's going to be 7, so we can save that request. No matter the size of the list, you could have 10,000 characters in your list. It's always going to be better than the bisection method. One of the cons, though, is it requires 2 different parameter values. So you have like maybe ID equals 1 or ID equals 2. You need 2 of those. And I can adapt the method to use just 1 parameter value, but it would not be as effective. So when comparing this method with other methods, here's just a chart, like say the character sets. In my methods in blue, And then you see the bisection method in red, and then the bitwise methods are the yellow here. So just for the character set there, you see a 47% improvement. Retrieving the hash for MDM ABC123, the MDM5 hash, 29, almost 30% improvement there. And then the quick brown fox jumps over the lazy dog, 35%. And depending on the case, like I'll show you, I've seen up to maybe 90% improvements, but that's not very realistic, but it can happen. So I'll show you a demo. My computer stopped working like 2 days ago. Just as I was coming here, I was like freaking out. I'm like, oh no, what am I gonna do? But luckily today it's decided to work fine. So here I'm just going to run the regex method, which again is like the bisection method, and I'm going to run it compared to my method at the same time. I'm going to try to run them at the same time. And it's just getting the hash password that I have in my database. Let's see. So you can see with my method, oops, right down there, it was able to get that hash in just 111 requests. Whereas with the bisection method, it took 183 to get the same hash. And it says, according to this, that if we would have brute forced it instead, it would have taken up to 291 requests. And I actually can slow this down a bit so you can see what's going on. Let's take the sleep off. So that's actually the method being implemented, extracting information from the database. So again, it's just pulling up the binary, it converts that binary back to its position, and based on the position, it knows what character it is. Here's the code for it. You can download it online. Someone else did it, not me. Okay, so let's see another demo here. So again, this is my methods, and then we have the binary search method here. We're going to retrieve the whole alphabet, or all the characters in the set. So running my method. Sorry, this is my method, but you can see how many requests it takes for each character. I just have the list ordered alphabetically. So starting with A, it would just take one request being the first position, but if you go down the list, it starts increasing. So that's what I was mentioning, that depending on the position of the list, the more requests it will take. But again, maximum, it's always going to be 6, and minimum can be 1. And then if we compare that to the binary search method again, you'll notice that the binary search is always going to be like around 6 or 7 per character. So this takes 663 or 633 requests. I didn't even notice how many mine took. Let me just run it again. 513. So that's a small improvement, but say if we were just to use a string like A, which it's only just one request, since in this case it's in the first position. So again, running it with the binary search method, just getting the string A multiple times took 174 requests. Getting that same string with my methods, 29 requests, so that's a huge improvement there. But again, just getting the string A isn't that realistic. Any questions so far? All right. Oh no, all the way back there. Now we're going to talk about optimizing queries, not just focused on blind SQL injections, but can be used for all types of methods. So we have queries that can retrieve all databases, all tables, and all columns with just one request. This is extremely useful. You can get everything in one request before they even know that they're being attacked. This is what that request, the injection looks like for MySQL. And it wasn't invented by me, but it's still important to show these. I actually have another demo. So that's just my test page. I'm just showing you that it's vulnerable to SQL injection. Simple blind SQL. Here I am going to the knowledge base that I was talking about that I created. Currently it just says MySQL, Microsoft SQL, and Oracle. So I was saying I try to put all my knowledge here in SQL injection. So we have retrieving multiple tables, columns at once, and you can basically just copy paste that as it is. All I do here is add a union, just so it'll reflect it back on the web page. Paste it in. As you can see, we have on the left all the databases. Here's all the tables, and then all the columns. And at the end, we have the username, email, password. I guess what we'd mostly be going after. Similarly, we have the same techniques that can be used for other databases, not only MySQL, but then we have Microsoft SQL. This is a simple one, just using XML. It concatenates all the tables and columns and stuff, or whatever you specify here. One for Oracle, using the extract function again with XML. And then Postgres. This one's using the array to JSON function. There's other methods you can use as well, but I'm just going to show one of each. So we also have other single requests that we can do to do a bit more devastating attacks. So one request for remote code execution. And what this request does, or this injection, it first checks to see if XP command shell is loaded. If it's loaded, it checks to see if it's active. If it's not, it goes ahead and activates it. And then in this case, it proceeds to run the dir command and stores the results in tempdb, in the temp database. This is what the query looks like. I added a little bit of formatting to it, like fonts, and just to, if it's a directory, just to put like the directory, the folder in yellow and stuff. And I actually have a demo to show you what this one looks like too. So here I have it in the SQL Server Management, so you can see it a bit formatted, what it looks like, a bit easier to read. And there I just have the area where you run the execute the XP command. In this case, it's just running the dir command, and we get all the results in just one row. So just copy paste it here so you can see what the results look like. Here I'm just going to change the command to something else, ipconfig, for example. Execute it. Again, we get all the results in one row, which is always important. Yeah, and then you get remote code execution with just that one injection. And that's possible because with Microsoft SQL, you can do stacked queries. So you can just have your attack like one query after another, just doing whatever you want. And a common misconception is that you need a semicolon for to put your next query, but you don't. You can just put one query and then one right after it, and it doesn't matter, it's fine. So a few more single liners. A lot of the time, testing can become very tedious, like it's a penetration tester. I see some horrible web apps that sometimes have several modules, like 900 modules, and each one has thousands of fucking parameters and stuff. So generally, if we're testing SQL injections, you have to do at least 3 different test variations, because you can have SQL injections with single quotations, double quotations, or no quotations at all. So you would have to test each one to see. I mean, you could have more of parentheses too and stuff, but we'll just keep it simple with these 3. So, I mean, if you're testing 400 parameters per module, I mean, and you have to do 3 tests per each parameter, you're doing like 1,200 requests there just for one module. So that can be frustrating. So I was thinking, is it possible maybe just to unite it, combine them in just one request? And yes. So with that injection there, it's possible to test for all 3 variations and just using that one request instead of having to do, so instead of having to do 1,200 requests to the server, we're only doing 400. And you can see the breakdown here, no quotations. Okay, that's supposed to be red. Can you guys see that? On my screen it shows red, but on this screen it just looks like black to me. But basically, no quotations is this part here, or 1, and then this is a comment. So if it doesn't use quotations, the comment will ignore everything else. But if we're using quotations, then the comment will just be ignored because it'll just be like part of the string. The double quotations is this area here. It's testing an or inside an or. And then the single quotations at the end too. And it's much easier to understand when you can see the red, but in this case you can't see it, so I'm sorry for that. In this case we're using the or logic, but it's important to be able to do this with and too. So with anding, this is the way we can do it. Although we're not using the and keyword in this case, it's the same logic, true or false, not equals 0. That would be true if it's not equals 0, the parameter that we're testing. And the same thing with the quotations there. So that's the part for optimization. Now we're going on to what people find a little bit more interesting sometimes is obfuscation, because this can be used to bypass firewalls, of course, and people like bypassing stuff. What's crazy to think is, I mean, SQL injections have been around for 15 years now, and that's crazy, like 15 years. So we've come a long way, like with our techniques to attack them. But as far as defense goes, I mean, the solution has been for most companies to just throw a WAF on there, like, you know, IDS, IPS, to try and stop them. And as some guy was saying yesterday in a talk, I mean, I'll be okay for, you know, amateurs or good hackers and stuff. Maybe it'll block them, or an automated tool like SQL map might not be able to bypass a firewall. But for any advanced attacker, it becomes trivial. It's quite simple. Like, it takes me a few minutes sometimes to bypass a firewall. So obfuscation, I kind of like this definition here. Just the art of making things appear more complicated than they really are. Again, this is supposed to be red. I don't know, it looks black from here. So this is an example of obfuscation right here. I kind of did this query, this injection here, just to confuse the shit of an admin. I mean, if you're an admin, you look at your logs and you're like, whoa. Like, what are your options there? You have 3 options, in my opinion. You can try and run the query at your risk, you know, see what it does. You could probably spend weeks trying to break it down, like each part and stuff. Or probably the easier is just quit your job. So how can obfuscation be used to bypass firewalls? Some tips when you're looking to obfuscate your queries is be familiar with the documentation. Go through the documentation and look for stuff that looks weird, unexpected behavior oddities, stuff that maybe the firewall developer or whoever implements or manages the rules for the firewall wasn't aware of, didn't know that function exists or that functionality. So if he doesn't know it existed, it's really hard for him to stop it or block it. Yeah, we can learn what databases are capable of and what they can handle. Fuzzing can help us find oddities and stuff that maybe is not documented. So again, if the developer or whoever trying to protect or the firewall is not aware that these exist, it's really hard for him to stop it. And again, just be creative, because sometimes like, you can think of a way that maybe the firewall developer, the core rule set maintainer didn't really think of, and again, he won't be able to protect against something that he wasn't expecting. Here's a simple PHP fuzzer I have, and what this does is really simple. it goes through the decimal, the code point 0 to 255, and it just converts that decimal to a character here with the char function. It inserts that character in a random place you can put wherever you want in your query. If the query doesn't execute successfully, it just continues on to the next character. But if it does run successfully, then it prints it out so we can see what characters are allowed in each space. This is an example of what it looks like. So here, we're just running it. We can see these are white spaces that are accepted. So instead of just the normal space, like the hex 20, there's a bunch of other white spaces get accepted, and then different characters that we can see here. So like I said, it gives us the idea, we can see what's possible, what's allowed in that database, and maybe something that they weren't expecting to block. And since most firewalls use regular expressions, they detect patterns, so if you can break that pattern, then it won't be able to detect it. Someone on Twitter actually told me that firewalls, their error rate is similar to an antivirus, which was around 30% mathematically. It's probably worse than that, but who knows. This is another fuzzer. It does the same thing essentially, but my fuzzer started getting a bit complicated. So again, I'm in Python. I pass it over to Python. This little snippet of just the whole thing. So I eventually start adding filters to help me go through results, because then you get just millions of results, and you have to really be able to search through them. So some of the results I found through these fuzzers, it's quite interesting. So just to talk about the white spaces, for example, with SQLite here, we have the standard white spaces like new line, vertical tab, horizontal tab, all these, the regular white space. So that's what a normal developer would expect for your white spaces in a database or anything else. For MySQL 5, we get similar results, but one that's extra here is the A0. That's like the no break space. And this is really interesting because it's not a common white space like other databases would have. So sometimes firewall developers don't know about the A0. So you can put that as a white space, and then it'll break that pattern, that matching pattern, so it can't be detected. It's also interesting to test, MySQL 3, even though it's not really relevant these days, but just to see how far MySQL has come and the differences. And this is the results I got from MySQL 3. So those are all the allowed white spaces. And when you convert these white spaces, like these ranges of codes, to actual characters, they look crazy. I'll show you in a bit. But yeah, MySQL came a long way from what it allowed before to what it is now. Again, Postgres, you get the similar white spaces what you'd expect, so that's good. Oracle 11 has a really interesting one, the 00. If you guys know, that's a null byte. So you can use a null byte as a white space, and a lot of programs or stuff will use the null byte to like terminate a buffer, or say this is the end. So that could really confuse a firewall trying to process the query. It sees null bytes everywhere. That could mess things up. And then last, we have Microsoft SQL. Similar to MySQL 3, it allows a lot of white spaces that shouldn't be there. So I was saying, like, when you convert these white spaces to characters, they look pretty funky. Show you. That's what an injection looks like. So good luck for a firewall trying to stop that. Sorry? Yeah, the firewall will smile right back at you. Oh, this is legit traffic. And if you don't believe me, here I'm actually running it in the console, and it actually returns results, so it works. So some more stuff I found through my fuzzers and just obfuscating and stuff. Start with MySQL, just some interesting tricks here. If you have a decimal, you can unite keywords, like in this case, union. So maybe a firewall is looking for the keyword union and trying to detect that, but once it's united with the one dot there, it becomes a different word for the firewall, so it doesn't recognize that it's just union anymore. Same here, you can have the decimal and just unite it. You can use exponents too, like one elevated 0 and put the U there. Here the /n is just a null byte that you can use to like unite, and then you divide that null byte between, again, 0 and a number with an exponent, and use that exponent again to unite the union. So here we just, this would be like one word for the firewall, and it won't know what that is. These, you might have heard of this one before. It's MySQL specific code. So basically, it's like comments, but you put a exclamation mark right here, and it allows you to specify a version. So that query should only run if it's this version or higher. But we can use that again to unite keywords, and this has been around for a few years now, so a lot of firewalls have adapted and implement this to look for it now. But still, maybe other firewalls not as good won't check for that. I really like this next one with the, with the back braces here, the curly brackets, because this is very unknown, and the TS is basically for timestamp, but you can really put whatever you want in there. So almost no firewall there will check for these curly brackets. And again, you can unite it with the union keyword here. And here, this is really interesting. I think this is a bug in MySQL that I found, because basically I can put 1E dot, and it converts that to just a dot. Or I can put any number .e dot, and it gets converted to just a dot. So when you're selecting maybe a column, MySQL supports the format of putting the database name first, then the table name, and then the column. But it actually doesn't care what you put as a database name. So you can put any, here in this case, I'm just putting a money, the money sign symbol is the database, and that's not a valid database name. Here for the table, I can just leave it empty, and again, I can put the 1.e dot, and that would just convert it to a dot, and then the actual table name. So that can be pretty confusing too. And again, you can use this dots trick in either when you're selecting the column or you're selecting the table. You can use it in different spots. We have similar tricks with, for Microsoft SQL. Same idea with using the .1 or the decimal to unite keywords. If you have an alias, you can just put it right next to the number 2. That's fine. Again, this is just stuff that will break the patterns that the firewalls are searching for and stuff, so it makes it hard for it to know this is SQL injection. I have to hurry up because you only have 10 minutes left here. This one is pretty interesting. Microsoft allows an empty hex, so you can just have 0x and leave it as that, and then we can actually put the union keyword right after. So maybe a firewall thinks 0x, okay, we're expecting a hexadecimal character here, but then it gets a UN, and that's not a valid hex, so it doesn't know what to do with that. Another interesting thing with Microsoft SQL is that the backslashes, it gets converted to 0. So you can just have a bunch of backslashes here, and it gets treated as a 0. With Oracle, we have like the F operator and the D, which this is like decimal, but you can use that again to unite the keywords here. Oracle is one of the only databases that allows you to encode or the table name or column name when you're selecting it. So you can put the column in hex if you want, or in characters and stuff. I haven't seen other databases that allow that. And then again, as I was saying, it supports null bytes, so you can just put the null bytes right in there. So sometimes firewalls will start getting very good at detecting your obfuscation. They can de-obfuscate your queries and then know exactly what you're doing. So in those cases, sometimes it can be interesting to do the opposite thing. Try and keep your query as simple as possible, because SQL has a very similar syntax to English, or it can. So instead of having something more obvious like union select, group concat, all that, we can just put pure like words there, and then it becomes difficult for the firewall to distinguish between English and what a real injection is. Here's an example of a bypass I had for mod security when they had the challenge. I don't have time to explain all of this right now, so sorry, I apologize for that. This is another bypass I just recently got for mod security, just to showing you keeping it simple again. Binary keyword is very useful for bypassing. You can put it before what you're selecting, or in this case true. You can put binary before, and you can have, I could have multiple binaries, so I can have case when binary, 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 just like 100 times, and that'll make it hard for a firewall. One problem that firewalls have is they call it the union select matrices thing. That union select matrices isn't necessarily a SQL injection, but almost every firewall would detect it as a SQL injection. So then you have the issue of false positives blocking legitimate traffic. So that's one of the big problems firewalls face. I was trying to get a union select from mod security, and it was very hard because they just detect anything that has union select in it. But I was able to get one using this trick, just using the mod operator, again using decimal to unite the union, and the no break space, white space there in between. Fortinet allows you to put any character above hex 80 in between keywords, and it just removes it. So you can put any characters in between, and it'll bypass Fortinet, no problem. Green SQL. This one, first I was trying to test it and set it up, and I thought I hadn't tested it properly because I couldn't get it to detect my SQL injections. Then I realized I was just really bad at detecting SQL injections. It was properly configured. Like, I just had a basic union select here with no obfuscation or anything, and it went right through. It was like the standard query, like injection. So I talked to the Green SQL guys. They said that's obviously an error bug. So they're working on getting that fixed. It basically seems to detect SQL tautology, so true or false. So and 1 equals 0, it detects at that, but then it was simple enough to bypass just adding like an exponent there, or again the binary keyword that bypasses it, or just using the if function. I didn't try any further because it was just too easy to bypass, but they have other interesting stuff that's worth looking at too. They also had a cross-site scripting in their comment box when I was testing out the software, so that's a little worrisome. Lib injection. Lib injection is the new SQL detection tool or library. It's implemented in C, so it's really fast, and it uses tokens, lexical analysis. So it's an interesting approach too, compared to regular expressions, but at the same time, there's a simple few bypasses here. And I'm running out of time again, so I can't go through them, but if you look at the slides, you know, it's all there. I colored what I thought was interesting of each part. So the funny thing is, these are all injections that I had reported, but again, you get the issue with false positives. So when trying to fix false positives, all the times you'll end up introducing, again, injections that had been fixed. You had they're back in. So all of these had been reported fixed, and then when trying to fix false positives, I tested all of them again, and these were all worked again. These are just some other interesting ones that I got for the injection. You can go through them later. So let's talk about encodings, 5 minutes. Euro encode is your basic encoding. Everyone knows Euro encoding. In your browser, you always see it. It's just when you have the hex here, there's the % right before that. And that's because you need to transform these characters, special characters, so they can be sent over HTTP traffic. And basically, A just becomes like the hex equivalent 61, and you just put the % sign right before it. Double Euro encoding is kind of the same logic. You just re-encode. You do a normal Euro encode twice. So in this case, the % sign gets encoded again, and it becomes 25, %25. So this is, all these encoding techniques aren't specific to SQL injections per se, but they're good if they can be used for any type of attack, really. It just really depends on how the application processes the data. So if the application is doing a double decode, this would work. So I wrote some tamper script for SQL map that allow you to modify the data that's being out, the queries that are being sent, to try and help you bypass firewalls. So one of the scripts I wrote is just char encode, and it simply does a Euro encode to the request. But what they mentioned is that it's useful for very weak web application firewalls. Well, I have a quick demo here just to show you how you can use these techniques. So basically, I'm trying to access Hakim's blog here, but it gets blocked by hacking by ironport here. What I can do is I just modify the A in this case and put a Euro encode the A. So I try Hakim again. By the way, this is an ironport that Cisco bought like in 2007, I think, for like $830 million. And then it's susceptible to this really simple bypass. Just takes a second here. So now we're able to load the website that was previously blocked as hacking just by Euro encoding in the host header one of the characters. That was enough to make it not detectable. Unicode encode is mostly supported by Microsoft. It's just kind of similar to Euro encode, but you just put a U00 in front of it. UTF, I don't have time to go through this one, sorry, but looking at the graph, You can you can find this on the internet. It's a known encoding already, multi-byte encoding. Nibble encoding, basically a nibble is 4 bits. So each one hex character can be represented in 8 bits, or 1/2 of a hex character is 4 bits. So you can represent the whole hex range here. You can see 0 to F and just 4 bits. So first nibble is the idea of encoding the first 4 bits only. So in this case, you'd only be encoding the 6, which becomes 36. So then it's %36 encoded at 1. The second nibble encoding is the same idea, but you're doing the last 4 bits instead of the first 4. Double nibble encoding is just a combination of both. You encode both nibbles, so the whole 8 bits. Invalid percent sign. This is really interesting. It worked with IIS 6, I believe, and basically you can put a bunch of percent signs. As long as there's not valid hex characters to follow it, you can put a bunch of percent signs in between your queries, and IIS will just remove them. So maybe the WAF will see something like this which doesn't recognize as a query or injection, but then the server will remove the percent signs and see what it really is. Invalid hex is another interesting concept. Basically, this is how you would transform from decimal or from hex to decimal. So 61, you multiply the 6 times 16, and then just add the second nibble here, the 1, and that gives you 97. So this is 61 is the hex for A, 97 is the decimal for A. So with invalid hex encoding, we're using characters that are not valid hex. So instead of here, for example, that after 10, or after F, you move on to 10 and then 11. Say we'd keep on going with valid hex, we'd go 0F, 0G, 0H, and when it's not really valid, but then it depends how the application again treats the data. If it transforms it to decimal, you might get the same value. Okay, quickly show you a screenshot of Leapfrog. Leapfrog, the tool I was talking about to help bypass firewalls. It works for different, well, eventually, right now I'm just working on the SQL injection part, but it's going to work for cross-site scripting, local file inclusions, content filters. It creates all its payloads dynamically at runtime, and when it finds a bypass, it will try and provide solutions, and then it gives you a score depending on how much SQL injections were passed through without being detected. So I call this the WAF acceptance factor, and I got this term based on the WIFE acceptance factor from Wikipedia, and basically this is like how much value an item needs to have, or based on an item, how nice it is, how much you need to convince your wife to let you buy it. So demo, it's just a screenshot I'll show you quickly so you can see the tool in action. This is an old screenshot. Actually, I should have taken a newer one, but you have the Leapfrog. Basically, it tests different encodings first, then it tests different terminators and stuff, and it goes on to testing more advanced injections. But I meant to release it a while ago, but I've been a little slow with the development just because I've been busy with a lot of stuff. But yeah, I'll be releasing it soon, and that's really all I have to show you guys today. My contact information again. I hope you guys liked the presentation. I think we're out of time for questions, but if you guys want to just come up to me later and stuff, ask me whatever, I love talking about this stuff, so please do. Thanks for coming, guys.